One might find it kind of odd to start talking about glaciers in such a landscape as this, but in fact, this landscape was in part defined by glaciers 20,000 years ago during the last glacial maximum, or the peak of glaciation. This landscape was covered in ice, and the glaciers were moving down valley, creating all the landforms that you see. But it took thousands of years for the vegetation to form that we now have right here and all around us. My idea is to take you on a tour from the lowlands to the highlands looking for evidence of glaciation and finally seeing glaciers. If one is lucky enough to come into a region and look at things from a broad perspective, just like us right now, you could start to guess whether a glacier has been in the region. If a valley is V-shaped, it's been carved by a river. If it's U-shaped, it's been carved by a glacier. And the valley behind me has definitely been carved by a glacier. So here I am sitting on this giant boulder in the middle of this meadow. And a good question might be, how in the heck did this boulder get here? Well, it has to do with the story of the glaciers in the area thousands of years ago. Thousands of years ago, a giant glacier came out of the valley behind and came down, bulldozing rocks as it went. And it picked up this boulder, put it on top, and moved it down to where it is today. Eventually, the glacier melted, and this rock was left behind. This is called a glacial erratic. Upon closer observation of the area, you can see that yes, there's vegetation all over the place. But there are also rocks of all sizes, like this boulder, or this rock. Or you could dig in and see that there's sediments, a pebble, or even smaller. And just off to my side, there's a rock the size of a house. This means that the sediments are poorly sorted. The rocks are also subangular, meaning that they have angles, but the corners are broken off. This is primo material coming out of a glacier. The hill slope that we're on, that has all of these poorly sorted rocks and sediments, is probably a moraine on the side of a glacier as it advanced down slope, bulldozing rocks as it went. The glacier has since receded, and we have this big pile of rocks left behind. Hopefully, as we move up slope, we'll be able to look back on where we are right now and see if we're right about our hypothesis. We're now above the moraine, where we were looking at the boulders and the soil. And you could see the moraine just behind me, that big long line right there. What's amazing is that you could see how this moraine formed. The glacier came piling over this slope, scouring away at this rock wall, pulling boulders off, and moving down valley and depositing it right on the moraine where we were standing. This is definitely a stop that we have to make as we make our way up valley. Right behind me is an extreme example of an old glaciation. These rounded rocks are called roches moutonnées, and this is formed by a glacier rolling over it. And the glacier not only freezes to the rock and plucks rocks away, but it has rocks inside the ice scouring away, creating these rounded surfaces. So now we're up close and personal with the slab that the glacier rode over, and we're looking for striations. And you could barely make it out on this smooth surface right here. There's striations. But the striations aren't everywhere, and it's not smooth everywhere. In fact, this is very rough. This is a neat example of weathering, differential weathering. This rock right here is not as hard as this rock right here. That's why we could see the striations, and here we can't. So now this is what I was talking about, but you have to get your face really close to the rock to see it. These are the striations, the grooves cut by the glacier with rocks in the bottom of it. You can see them up close. The higher and higher in the mountains that you go, the colder it gets. In fact, for every kilometer or 1,000 meters that you climb, the temperature usually drops by about 10 degrees centigrade. And this is called the adiabatic lapse rate. Right now we're at about 4,000 meters and the air is thin. It's hard to breathe. But we know that we're getting closer and closer to the glaciers. Glaciers are huge conveyor belts where you have snow accumulating at high elevations where it's cold. But this snow builds up into great weights and it also pushes down until it becomes ice. This ice and snow flows down valley following gravity where it reaches warmer temperatures and it melts. Where it melts, it's called ablation or the ablation zone. So you have buildup of snow to thawing, buildup of snow to thawing. So we finally moved our way high enough so we can see glaciers. And this is the Korikalis Glacier on the Calcaya ice cap. And if you look carefully at it, you can see cracks in it, and those are called crevasses. And if you look off to the sides of it, you can see that there are piles of earth. And the idea is that this glacier was once larger than it is now, and as it moved down, it scoured away the rock that's on either side and created these piles that you can see. Those are called lateral moraines. And if you look at the front end of where this glacier bulldozed down, that's called an end moraine. And we'll hopefully be able to see that in just a second. So now we're looking down valley a little bit more at the Korikalis Glacier, and we can see the end moraines, the terminal moraines of the glacier that happened about during the 1800s, 1870s or so, when there was a cold snap. And the farthest moraine that you can see is the coldest point. And since then, the glacier retreated. Right now we're about 200 meters above a glacier that's covered with rocks. We're on top of one of those great moraines that's been built by the glacier. But the rocks down below us are also on top of the glacier and act as insulation from the sun. So this glacier that's motoring down the valley can go lower in the valley than a glacier that's not covered. Being on the glacier, the equation changes. We have to think of safety first. So I have crampons on my feet, and I've got an ice axe to stop myself in case I slide. And I'm going to tie into a partner so we can walk together in safety. But we're going to make our way up the glacier, looking at the different forms on the glacier, and possibly understanding how it works a little bit better. So let's head on up. From a high vantage point, you can see the anatomy of a glacier, where snow accumulates at high elevations where the temperatures are cold. Under its own weight, the snow moves downhill, and in areas of tension, crevasses form. Eventually, the snow reaches warm temperatures down low, where it begins to thaw, and this is called the ablation zone. With enough thawing, a lake can form, and the water is usually trapped by a moraine. Right behind me are some crevasses. And crevasses form in two different ways. You can have a glacier move over a bump and just like an accordion open up, or a glacier can turn a corner, and at the corner the glacier is going to slow down and it's going to open up as it rounds the corner. So at the far side of the bend you're going to have crevasses opening up there too. We're finally high within the Peruvian Andes, and the weather's giving it all to us. We're thousands of feet above where we were before. This is where it all happens. Snow accumulates and makes its way downhill due to gravity. But this brings into question, there has to be a balance. There has to be a balance between the amount of snow that accumulates up here and the amount of snow that ablates or melts down below. What if there's an imbalance? If there's an imbalance, then the glaciers shrink or they become bigger. And this is a big question that comes into mind for a lot of the people around here. Right now, Peru depends upon the snow melt from all these glaciers for a number of reasons. For agriculture and for 80% of its power, hydroelectric power. Over the past 35 years or so, 30% of the snow and ice that's held within the Andes has melted. This means that the resource that Peru values so highly is disappearing. What do we do about that? What does the world do about that? What do the people in the third world country of Peru do about that?